hope everyone is safe at home. I hope everyone is doing well. So last class, in the last video lecture, we have discussed about free electron theory. So in this we discussed classical free electron theory and quantum free electron theory. And classical free electron theory will have some drawbacks. So those drawbacks rectified by the quantum free electron theory. Now quantum free electron theory, again it will have some drawbacks. That means based on that theory we could not explain few things, basically mainly. So quantum free electron theory could not explain the distinction between metals, semiconductors and insulators. So these things it didn't explain. And also the positive value of the Hall coefficient. So that these two are mainly quantum free electron theory didn't explain. So now in this video, now we try to explain these things, how these have been explained based on the band theory of the solids. So in this video I am trying to explain those distinctions, that means metal, semiconductor and insulant based on band theory. But band theory I could not go into detail, so that I will do another video lecture. So now I am taking the only important things from the band theory of solids. So that from that I try to explain about the semiconductors and those things. Okay, now let us see the experimental values which were already is there in literature, that means textbooks. So where if you see the values of a different metals like copper, if you take a copper, the resistivity values, electrical resistivity values, it is 1.7 10 to the power minus 8 ohm meter. And for the wood, so that we call it as an electrical insulator, that is 10 to the power of 14 ohm meter. So which is more. And germanium, if you take another material, germanium, 4.6 10 to the power minus 1 ohm meter. That means if you see these values, experimental values of the three different materials, the resistivity of the copper is very, very low. That means resistivity is a inverse. So inverse of the conductivity. That means electrical conductivity is more in case of copper, because as you know that resistivity, that means it is rho. That means conductivity sigma is equal to 1 by rho. If rho is more, that means sigma is less, electrical conductivity is less. So in this case, wood resistivity for the wood, it is electrical insulator. That means the conductivity is very, very less as compared to these things. Okay. So like this, if you take a metals, if you take a aluminium, gold, silver, like this, if you take a metals, then if you check the resistivity values of those things, it is in this range. And if you take insulators, especially wood, you take glass, you take, there are different materials, wood, those insulators resistivity values are like this, which is always higher. But if you take another material like semiconductors, so semiconductors, their resistivity values are intermediate between these two. So like this, semiconductors will have a resistivity value, that is conductivity values intermediate between this conductor, this we count it as a conductor, this is insulator, this is a semiconductor. So from these values we have to explain why these values are having like this. Different materials, all are solids. Solids, again solids will have a different kinds of electrical conductivity is there, that need to explain. So free electron theory cannot be explained, didn't explain. And from quantum free electron theory, from that also we didn't explain that one. So now we try to explain this thing by using the band theory of the solids. So now we are moving into the band theory of solids. We would like to know some basic concepts. Just I want to give some glimpse of those basic concepts. So let us see. Now let us see sodium atom, that means metals. So same example we have taken for the to explain classical free electron theory also. So now if you take sodium atom, The electronic configuration of the sodium is, as you know, 1s2, 2s2, 2p6 and 3s1. So 11. Okay. So atomic number is 11 electrons is there. Now this is a nucleus and 1s and 2s, 2p and this is 3s. This we know. Now if you take electron is here. So 2 electrons, 1s2 means 2 electrons are there. So these 2 electrons we know, one is spin up, another one is a spin down. That you know very well. So according to Pauli's exclusive principle, these 2 electrons, one is spin up, one is spin down. Now this electron, it is in s orbital, 1s orbital. So it is nearer to the nucleus. That means from quantum free electron theory, there we mentioned that electrons having the energies, okay, those energies is not a continuous, it is a discrete energy levels it will have. What do you mean by discrete energy levels? So before that, that means energies are not continuous. That means 1 electron volt, 2 electron volt, 3 electron volts. So there is a gap is there, that values. That is the discrete one. So now again everyone will have a doubt that what is the energy, which energy we are talking, why, what do you mean by this energy level, where this energy level is coming. So these questions will come into our mind. So now let us try to be simple to understand that energy. So for example, if you take 1s electron is here, it is revolving around the nucleus, that we know. So here electron is having the positive negative charge and nucleus is having the positive charge. That means this nucleus always try to pull the electron towards the nucleus. That is the Coulomb force. But electron never go into nucleus. It is pulling, the nucleus is pulling that electron, but electron is never go inside. It always rotating right. That means what that we can understand from the electron is also try to resist that attractive force. Is it right or not? So otherwise, obviously electron will go into nucleus. So it will try to pull that, it will try to oppose that attraction force. So how much is that attraction force? The same force, whatever the how much force it is pulling, the same force it is also opposing that force. Both are same, so that it is stable over there. So that means electron is doing some work. So again let's look at that force. That means electron should have that energy. Otherwise it cannot sustain in that orbital continuously. So it is sustaining that orbital continuously because the atoms are stable atoms. That means electron is stable in that orbital so that it has some energy. So that energy is what? So that energy. So 1s electron, if you take that energy, and you take it that level. This is the energy level of 1s. Okay, this is the 1s energy of the 1s level energy. And now it will have 2 electrons. So according to Pauli's exclusive principle, this energy level can be accommodated by 2 different electrons, not same electrons. Not same electrons. So one is spin up, another spin down. So both will have the same energy level 1s. Is it right? So electron energy level, this is one energy level. And again you take it 2s. That means again 2s will have energy level is like here. Again you take 2p energy level is here. And again you take 3s, this is energy level is here. That means these are the energy levels of the electrons, different electrons. So 1s electron energy level is like this, 2s electron like this. Now what is this energy level? This energy is more as compared to this energy. Why? Because this electron in 1s orbital is close to the nucleus. That means the more Coulomb force is there as compared to 2s. Because 2s is farther from the nucleus as compared to 1s electron. That means it don't need much more energy to oppose the Coulomb attraction force. For this it is needed more energy, for this it is less energy. This energy is less. But it is showing, I am showing that because these energies are negative energies, because simply it is coming from the attraction force. So these negative energies like this it is coming. So these are the energy levels of the electrons. So these levels are discrete energy levels. I hope you understand energy levels. Now it is okay. Now what happens in case of solids, that we have to take, because this is only one atom. Now for example 3s, it is a valence electron, one electron is their valence electron. Now if I take another atom, same sodium atom, if I take another sodium atom, now if I take it to the closer to this here, very close to here, so then what will happen? That means again if I take another sodium atom, and this is 1s orbital, so this is 2s, this is 2p, this is 3s. Okay, so what will happen here? Again 1s electron is there, 1s electron is here. Now in case of solids, so these two atoms are packed. Okay, packed. Now if I take, this is a complete system. Complete system. Earlier for this only single atom, energy levels are like this. Okay, so these energy levels are like this. 1s, this is 2s, 2p, this is 3s. Now in the system, now we will have two atoms are there. So two atoms will have, again here there are two electrons will be there, one is spin up, one is spin down. This is of the same atom, sodium atom. Now for this system, what is the energy levels here? Because here is this spin up electron, if you take a spin down electron here, this is spin down electron here. What is the energy of the spin down electron? This one. What is the energy of the spin down? That is also same thing. Because there are same atoms. This is also sodium atom, this is also sodium atom. So energy of this electron is also same, energy of this electron is also same. So but according to Pauli's exclusion principle, no two identical electrons accommodate a same energy level. That means these two are closed, okay, but for this system two energies existed for the same electron. It cannot exist. It should not be same electron. That means same electron, energies are also same. It is not possible according to Pauli's exclusion. So that means what should have, whenever it is coming, another atom is coming, that means there is another energy should come. That energy also 1s, that is also 1s, but it is not same, both are not same. There is a small difference will be there. Very small difference is there. Now if we add another nucleus of the sodium atom, now another nucleus if we add, now the three atoms in the system, then what will happen? Again the small energy level should create for this one. Now if I take another one, another atom if I add, then what will happen? There are so many closely spacing energy levels will be there. So these closely spacing energy levels will be formed for the solid, because solids, all the atoms are very tight each other, and there are many number of atoms will be there. So when n number of atoms will be there, the energy level is always like it should see like a continuous energy levels, but it is not a continuous energy level. There is a discrete energy levels for the particular orbital. For example, for 1s, it is coming like this. There are so many n number of energy levels. There are so many number of energy levels are there. That means n number of atoms will be there. That 2n number of, for example, n number of atoms will be there here. 2n number of energy levels will come, because 1s and 2s. So spin up and spin down. That means this will look like a band. So then it is called energy band. This is energy band for the 1s orbital. 1s electrons in the 1s orbital. So electrons energy is in the case of bands. Like this 2s, like this 2p, like this 3s. So this is what we understand broadly, in sense broadly, that energy bands, how well they are forming. So this is schematic. So if you go in little deeper, the energy band diagram also will vary according to distance, because when two atoms are in this distance, energy band looks some other way. When two are very close to it, then band is very different. That depends upon the internuclear distance, that means distance between the two nucleus. That will be changes. We will discuss it in the later. It's in the band theory of the solids. So from this, what I want to try to impress upon this is that when the n number of atoms are there, whenever these two are close to each other, then the same electrons energy is the same, but according to Pauli's exclusive principle, it cannot accommodate at a single energy level, so that many energy levels will be created. It will have many energy levels. These energy levels doesn't have a different more difference is there. Very infinitely small difference energy levels are there. Because of infinitely small differences are there, so we cannot observe the discreteness. So it looks like a continuous. Because of the continuous, it looks like continuous, that forms like a band. That is called energy band. Okay.